All right, good morning, everyone. I appreciate you joining us on day 2 of boot camp. We're going to get started here. We're going to kick things off in 1 minute with Pete Vanderstappen, who we heard from yesterday. But I just wanted to remind everyone that we are keeping track of attendance, and we're also keeping track of participation. So we have questions throughout the morning that we'll have you answer, and not looking for necessarily all questions to be answered, though that would be great, but we are looking for most things to be answered and to show participation throughout the morning. So for those looking for credit, make sure you're participating. And we had great participation yesterday, so I expect the same today. I appreciate yesterday's everybody's time and efforts that they spent. So with that, we're going to kick it off. Pete, if you wouldn't mind, Pete, that as a reminder, is our state conservation engineer, and he is also our acting state con for Pennsylvania NRCS right now. And he's going to talk to us about inventory resources. So, Pete, it's all yours.
Okay, Tim, and I assume my screen is up on the screen already. So,
yep, looks good.
Okay, very good. Well, hey, good morning, everyone, and welcome to day 2 of the virtual boot camp. As Tim said, my name is Pete Vanderstappen, and I'm going to put on my state engineer hat today. Just some quick background on myself. I started about 40 some years ago as a student trainee engineer in Virginia. Worked a couple years down there. Came back to Pennsylvania and bounced all the way around back here to Harrisburg. My actual background, I was raised on a 40 cow dairy farm in western PA up in Crawford County. And to this day, my sister and her kids they're milking 1,000 cows, and my brother's milking 300 jerseys. So still deeply embedded in the farming background, and we'll hope some of that knowledge gets transferred to you folks today, or at least some ideas anyway. So let's talk about inventorying resources. So we're going to take a look at if you haven't heard about it already, the NRCS 9 steps of planning. We're going to take a look at basically the first 3, and these are to identify the problem, determine the objectives, and inventory the resources. And the last part of this statement is it's a team approach. It's just not myself going out looking at someone's farm or you going out. It's a team approach of the landowner, the decision maker, maybe a conservation person, maybe an NRCS person, maybe a funding person. It's usually a team approach when you take a look at these things. Usually 2 or 3 people looking at the situation at one time. So I always think the thing I always look at is, why am I going out to the farm? Did the farmer invite us out because he's really truly interested in the conservation? Are we going out because the farmer's interested in a cost share on some practices? Maybe there's a situation where someone stopped by and said, Mr. Farmer, that you have some issues out here. Or maybe DEP has stopped by and said, man, you don't have an E&S plan, or you don't have a manure management plan. You ought to contact the Conservation District or NRCS. So always find out why you're going out there is always a good thing to do. And certainly a follow-up to that to be, the decision maker, what their objectives are. Are they trying to keep in compliance? Are they trying to get cost share? Or they finally decide they want a manure storage? Whatever. You need to find those things out. And then the big thing is, when you're out there, you want to collect enough data, a data set for all the resources, so you can come up with some alternatives. So sources of information, obviously if they already have a conservation plan, and if it's current, you should take a look at that. Lots of times a farmer may have a nutrient management plan already done. A lot of good information that you could take out of that for animal numbers and those kind of things. Some farmers have a history with us, with NRCS, and you'll have previous site reports. Farmers do not make up their mind right away. It might take them, several years to come to some conclusion as to what they're really going to do. So sometimes we have old trip reports. It's worth looking in the files and seeing what those are. Hopefully, if you're in an office that's been around a while and you're new to the game, they may have a history with that particular landowner, and they might shed some information on that. I put in here site topo, but not too many people use site topos anymore, but certainly an aerial site from Google Earth is really a good starting point once you get an address to take a look at that and kind of get an overview of, especially, and I'm going to focus today on headquarters. So check the files. Here's some old file folders. Maybe we don't use those much anymore, but they still are out there. Check those. And the other thing I put in this particular slide was educate yourself. So if you're new to conservation or new to that type of operation, like I had a background in dairy, but if you had a background in poultry or had very little background in any different types of animal operations, there is an opportunity to go take a look at under the Ag Waste Management Field Handbook, Chapter 9, Typical Agricultural Waste Management Systems, and there's a directive to get to that. So take a look at that. The Field Office Tech Guide has a lot of good stuff, and also the Penn State Ag 101. So, it'd be really good if you're going out to the first time you've ever been out to a hog facility, take a look at here, read up about swine, get some general background information. So when you go out and talk to the farmer, you got to get some background information to help yourself out. Talk to someone who knows about the site. We talked about that. Someone in the office, those kind of things. Check around. That might be worthwhile to know. And kind of the weird thing is sometimes you talk about, oh, that farm is a great farm, but watch out for the dog. They might bite you. So be careful when you go out to these farms for animals and stuff. Those kind of things. The last comment I want to make here is really good. Detail should cover the entire yearly cycle. So be aware when you go out to if we're in a dry condition and you're going out to look at an operation during a drier condition, it's going to look like one thing in the middle of June. It's going to look a lot different in maybe February or March, even if there's no snow in the ground. So the type of year and how much rainfall we had can really vary what a site looks like. So take that into consideration when you're looking at the situation. So aerial photo here is a good example of using an aerial photo. Here you can see the operation, and you can see to the left side is a big barren field. And was that plowed or was that part of an ACA? Probably the one section, the big field, is probably a tilled operation. But if you look to the barn, and just to the left of the barn, you'll see a square pad, and then also see it looks like a pasture, and it looks like that section of pasture is pretty abused there for several thousand square feet in that section there. So you get an idea that the animals are concentrated in that section. So you get a perspective of what the farm looks like on that particular day when that photo was taken. But you'll go out there and have a chance to check it out yourself. Work with the decision maker. It's always good to meet with the farmer, and sometimes the farmer may not be is the owner, and sometimes they're the operator. Or in this particular case, we had a technician, our DC, and the farmer was there, but he tells us that his dad still owns the farm. So we got a gentleman here that's 45 years old, and his father really owns the farm. And maybe in the background, his father's making the decision of what to do, to spend money or not to spend money. Walk over the entire site with the decision maker and find out what's going on. Just don't walk up to the front of the barn and look. You got to walk around the entire farm, especially on headquarters. Walk all the way around, check everything out. You got to walk the ground, check it out to make sure that you can see everything. Because sometimes what you see from aerial photography is not correct anymore, or maybe the farmer doesn't think it's a resource concern out the back, but you walk out there and maybe that's a bigger problem than what the farmer has brought you in for. So definitely walk around the operation. Document your findings. I'm getting older. I forget a lot of things. And I think some key things are take photos with permission. Take a lot of photos. I think those are a really good way to document things. From the engineering side, you can, did that barn have a roof gutter and downspout? Just take pictures of everything you can while you're walking around. Certainly gives you something to look back on and to really fine tune your trip report. So write down what you need to have. And I show in this one lower left-hand corner, we do have a 7 or 8 page data sheet. That's really a great tool to collect data. So if you're going out for the first or second time or several times even, I use this 8-page form. It reminds you of the data you need to collect, because you hate to have to go back out and ask questions again. So definitely think about using that form, and I'll see if I have to go to take a look at that form here. Okay, we won't. Anyway, next one, here it is. So here's a 1, 2, 3, 4. It's a 7 or 8 page form. It's really a nice tool if you want to make a hard copy to fill out the blanks, gather some information, and document what you're looking at. It's really a big help, especially when you do an I&E farm with multiple animal units and all these numbers. It kind of organizes your data collection and also reminds you to collect the data. So it's on our, it is available through our NRCS site and readily available. So definitely pull that form off the NRCS site and print out a couple copies, and you'll have it with you on your next I&E. So the one thing we're challenged about in Pennsylvania is I talk about coming up on a dairy farm, but there's a lot of other operations in Pennsylvania. You know, we have I think over 5,700 dairy operations, but we have a lot of other things like goats. We have a lot of small beef operations, and we have a lot of poultry, turkey, chickens, broilers, you know, all those kind of things. So we have all kinds of operations in Pennsylvania. Each one is unique. The size of operation. You know, we think of, like I talked about my sister having 1,000 cow dairy. Well, here's an example. Here's a small dairy farm up in Perry County that probably only had 20 cows, which is pretty rare these days. You have Amish farms, and on the upper right-hand corner there, I call it the world's smallest animal concentration area. That happened to be a kid that had a 4-H project, and he had two animals on that farm. So operations come in all different sizes, from a couple animals up to probably I think the most cows in Pennsylvania is around 3,500. So all kinds of sizes out there. The other thing you got to take a look at is site location. Site location can really affect what the producer can do and what we can recommend as alternative solutions. So near or far to the road it sounds like an easy one, but if they're right on the township road or state highway, there might be limitations what they can do out the front of the facility. Are they in an urban or rural setting? You know, are they in the middle of a housing development, or are they in the middle of a farm country? The other thing we got to take a look at is typically when we do on headquarters, we may be looking at potential to build manure storages or animal concentration areas, roofs and covers, and those kind of practices. Is there space to do that expansion, or are they hemmed in by a township road, other buildings, their house, you know, all those kind of things? And the last thing to take a look at is required setbacks. Some townships have a minimum setback for buildings and stuff like that, but from NRCS point of view, and well, you heard some regulatory stuff yesterday through Act 38, that if you're building a brand new storage on an existing operation, there's different setbacks from property lines and those kind of things, or they have to get a waiver to build those things. So all these things can, kind of play in the process, but as you're walking around the farm, taking pictures and talking to the producer, you'll find all these things out, approximately where there's a property line and all those kind of things. Topography can also make a big difference. Here, an example on the left-hand side, pretty steep operation. Certainly, that has some advantages. It's more difficult, but in this particular case, if this particular farmer wanted to use gravity flow, which pushing the manure out of the barn into a gravity hopper and using gravity to move it downhill to storage is a possibility. But where the cows are on the right-hand side there, maybe that the operation is too flat and gravity flow is not an option. They'll have to do some pumping system. So, topography can make a big difference on what kind of the options are out there. So be aware of that while you're walking around. Soils. Obviously, every farm has a different soils, and each one of you folks, no matter what county you're in, over time, you should have a pretty good idea what the predominant soils are in your particular county. And that can be a big help, because then you can look at a soils map, and maybe you can identify that you're in some parts of some counties, it's karst topography, a lot of limestone. That certainly could have an impact on what kind of structures we could build, or the extra costs involved in removing limestone. It also can give us an indication of sinkholes, which could be very problematic for soils, or it could tell us we have really good soils and good drained soils, and water tables and those kind of things will not be an issue. So understanding your soils is really critical. And you won't do that on the I&E, but certainly you get to see the lay of the land. Maybe you'll see limestone outcrops all over the place. So that kind of gives you an indication what you look into. But here an example, we're doing test bits, but that's not in this particular phase yet. But understanding your soils can really help you out. Geology of the area, like I said, take a look at which county you live in. And here's a general map here, but are you a limestone, shale, sandstone, schist, conglomerate? Are you in materials from glacial soils and all those kind of things? But get an idea of your county, and once you kind of get a general scope of what's going on, you'll get some better sense of the issues that producer might be facing, because he's on shale ground, which gets a lot drier during drought conditions, good clay ground that holds moisture in a drought condition, shale, limestone. All those things can maybe a factor into your decision-making process. So all these things kind of affect the length of storage. And what we're talking about, let me go back one here. Oh, climate. Okay, climate affects the length of storage, may affect manure handling options. So we talk about, this is kind of, slide was put together before we talk about climate change, but certainly we know that in Pennsylvania, there's a significant difference of probably 2 to 4 weeks of difference from the north part of the state to the southern part of the state. And that can really affect our storage period. So in the northern part of the state, we probably opt for a longer storage period because winter just seems to hang on longer. The ground has more snow cover. So that definitely will affect your storage. It also affects how you might handle your manure, whether you're going to be able to spread it or land apply it in different methods. All those things come into play. And the other last thing is rainfall rates do vary from county to county, and that can certainly affect your storage volume to a degree. The cropping rotation that the farmer has is another thing that's going to, you normally don't think about that on your I&E at a headquarters, but certainly on when you're walking around the farm and you're thinking about manure storage case, we always think about manure storage is a winter situation. Where am I going to store the manure typically in Pennsylvania from maybe sometime in November through right now through the end of March, through the end of February or March, depending on which part of the state you're in. We also need to take a look at crops. If you have a landlocked farm that has all their available land in wall-to-wall beans and corn, they may have a situation where during the growing season, like right now in Lebanon County, I saw they're starting to plant corn. So once they put the corn in the ground, it's going to be August, till they take off the silage. The summer might be just as critical time to have some storage available if the cows aren't on pasture. If they have manure, if they have confined operation, they may need to consider what's the storage period over the summertime could be just as critical as over the wintertime. So that and the type of crop rotation may affect where he can haul manure. If he has fields available during the summertime to spread manure on, then that might not be a critical situation. And you may be able to look into if he has a well-developed nutrient management plan, maybe he does have a crop rotation that he's taking off small grains and stuff late so they can apply manure midway through the summertime. So take a look at that. Crop scheduling could affect the storage, especially over the summer run. And that also may tell you that they need to export manure, find other places to get to it, or stockpile it. The pasture system can also something you need to take a look at how they're managing their cows. It could impact the manure sizing and usage. If the cows are if they're on pasture, obviously over the summertime, a lot of manure is not going to be collected in the barn anymore. It's going to go out on pasture, so that might be a good thing. It's going to impact the type of best management practice it's going to use, and I think you really need to evaluate as part of any system. On the engineering side, you need to communicate with the planning folks on the pasture side. So if that particular producer is definitely going with his milk cows, they're going to bring them in twice a day to milk them, but the rest of the time they're going to push them out the pasture. Then they need to have access way and a pasture grazing system to make sure they have a place for those cows to graze. And if they don't have enough pasture, we certainly want to avoid the situation of generating like in the upper right corner there, you have an ACA going on there where the cows are just loafing out on the ground there, but it's not really a pasture anymore. So now we have manure deposition going on, potential nutrient issues and those kind of things, versus a controlled system below where we have a animal trail and walkway and they can rotate the cows through a different pasture complex. But folks, if they don't have enough pasture or we get in a drought situation, they may need to pull those cows off the pasture, bring them back to the barn. And are they going to keep them inside the barn? Do they have enough capacity for that? Do they have a concrete lot or a concrete lot with a roof to keep them in there and feed them supplemental feed? All these kind of things need to be kind of discussed to see which way that farmer is going to go. Or maybe that's part of the resource concern that you've identified. Labor availability. I always think about this. Is it just the owner and his family? They're certainly not going to come up with sometimes we have very economical alternatives, but with limited help, they may want to obviously streamline the operation, minimize labor, and do those kind of things. So just kind of knowing what the situation is. Do they have hired help, seasonal help? And most farmers always want to design to reduce labor. They don't want to get off that piece of equipment and use a shovel and a fork anymore. The kid only wants to use a skid loader to move stuff around. So some of those things come into play in the design phase, but it's certainly good to know what kind of labor force or labor availability that landowner has, or get a sense for that anyway. We also need to take a look at the manure transfer equipment. How is the farmer moving his equipment around? What's the existing system? Does he have an automatic scraper system in the upper right-hand corner there? Does he have a lower left-hand corner? That's actually a box used to, it's a shuttle that runs horizontally across the barn, and you can actually drop manure into sand-laden manure if you need to. It'll actually grab that manure and shuttle it across and drop it at the other end. So, and the old style tire tractor with a tire scraper. So we need to take a look at what kind of equipment he already has, what equipment he's willing to change to. And the other thing is, let's say he daily hauls a pen pack manure or a box stall manure or just the gutter cleaner, and now we're going to build a manure storage. Is he going to now use a custom hauler to haul his manure? Is he in a location, he or she in a location that they do have custom haulers? So all these things kind of sometimes affect what the landowner wants to do and how he transfer his manure around. The same thing with once you move the manure from where it's produced into a storage, you now have to get it out in the field. So a couple different examples here. Upper left-hand corner is an Amish operation with a small pump transfer system to their system. The lower left-hand corner is a pulse jet. You don't see too many of these in Pennsylvania, but basically they can take the liquid fraction of the manure at about 2% solids, and they can actually irrigate it using that method. The more conventional method is the upper right-hand corner. Here's where they're actually transferring manure with a large, maybe a 10,000-gallon tanker and a nurse truck, and they're pumping it over and then pumping it actually into the manure spreader that's running the field. So they're transferring manure from the storage to a tanker. Tanker runs it down the road several miles, and then they actually transfer it into the manure spreader, and they actually spread it on the land. And down below on the lower right-hand corner is more of a typical, we have an agitator in an old-style lagoon. They agitate the manure up for a couple hours, and they start pumping it into the tanker, and they'll haul it out to the field for direct application. So multiple ways to unload and apply the manure, and those are the kind of things you need to find out what the farmer's doing today. And if he's switching from solids to liquids, you need to know that, so that'll make a big decision on what he plans on doing. Level of management, I hate to say this, but you got to take a look at all these farms and take a look at the upkeep. Equipment outside versus buildings inside and well maintained. Equipment inside. Sometimes we got to think about when we actually do designs later down, we try to make them more fail-safe for poor managers. But regardless, just take a look at the level of management. That might indicate what we ought to plan for to make it more, I hate to say bulletproof, but keep those things in mind, because we certainly don't want manure storages to overtop. Animal housing methods. There are all kinds of ways to house animals in Pennsylvania. On the left-hand side, they're using corn fodder bedding for the smaller heifers and calves. And on the right-hand side, you can see a little bit residuals there, but they're actually using a flush system to flush the manure and sand down through the barn. That barn's probably on a 1 or 2% slope. Just some more examples. A typical right-hand side will be the old tie stall barn, probably using some sort of sand bedding there with a gutter cleaner system and sand bedding, versus on the right lower side, some sort of composted bedded pack. If they, that's one term you need. A composted bedded pack means that twice a day, the farmer actually brings equipment in there and stirs that surface up to aerate it. So, and he adds extra bedding. So that pen pack is not a pen pack. It becomes a composted situation where it probably gets 3 to 4 feet deep, versus a pen pack is just where you add extra bedding every day and build up a pack of manure. So big difference between a composted bedded pack and pen pack. So travel routes, part of the process is if we're thinking about manure storages and those kind of things, where is equipment moving around? He needs to be able to keep moving his equipment around. Where's the milk truck come in? How's he going to fill his silo? If he's thinking about expanding his operation, most farms, less than 100 cows, they might have these vertical silos. But if they start getting 200-300 cows, they're going to start thinking about a bunk silo complex, which would be a big concrete pad, and how they're going to feed to that pad and move that material from the pad to where the cows are. Feed equipment is also, like I said, a concern, and the cows got to move. Cows can walk, and they have to move from the dairy barn to the milking location out to pasture. All those things will factor into maybe some of the options that are not available for that particular operation. Odor resource concerns are always something to think about. Neighbor complaints, fly issues. Typically, don't see fly issues with dairy, but certainly can with poultry if they don't manage their manure and scrape it at least every 7 days. Odors from manure application can be a problem, and you folks will notice that maybe when you rode into work today. A lot of farmers are starting to apply manure, or they have in the last couple of weeks. Odors from improper animal mortality, we don't see that too often, but certainly you need to take a look at what they're doing through animal mortality. And you heard yesterday about the regulations. Some farms, depending on the size, they need to have an odor management plan. And there are other related issues, dust from driveways, harvesting off dry lots, etc. And these things all are going to tie into as NRCS moves to the future about global warming, but also greenhouse gas. And we also take a look at particulates, especially the 2.5 dust coming off driveways, harvesting soybeans, and all those kind of things come into play. Energy resources, another thing we can do with NRCS, looking at electric bills, especially if they're not using LED lighting. They don't have variable speed drives in their pumps. They don't have a plate cooler. Their ventilation fans are dirty. All those things are certainly opportunities that you may want to mention to a landowner. That, hey, if you're out there on the NRCS side of the fence, you may discuss that we do have cost share for those kind of things. And we also talk about the fact is that as we promote conservation, we're into reduced tillage, less passes over the field, less energy use. Certainly they can take a look at if they have a grain drying operation. If that grain dryer is 20 years old, it's probably time to upgrade. And the last thing, pretty rare on a dairy farm, would be some sort of an irrigation system. Laws and regulations, I'm not going to get into too much, but I think this is a factor that really plays into the whole planning process. We go out there to identify resource concerns in the first 3 steps here. But boy, if you get down to it, laws and regulations can really slow the process down. Does the township require a land development plan? Is he a CAFO or CAO, odor management plan? Are there other zoning ordinances? Does he need is he an Act 6 protection or participation? Certainly a nutrient management plan. Needs a conservation plan or a Chapter 102 plan. NPDS Phase 2 E&S plan if he disturbs over 1 acre. Setbacks, all these things, maybe not that critical in the first 3 steps here, but they're going to affect maybe some of the things you do and the pace at which things could get done. The other thing we didn't talk about is utilities. Definitely take a look at buried gas lines and overhead poles and electrical utilities. They may play a factor in site layout or options you may want to talk to the landowner about where to build a manure storage and those kind of things. Water quality issues, typically something we really look closely at, especially if you have a concrete barnyard with no controls. Where's that runoff going? And we're looking at, they need to contain up to the 25-year storm, which is 4 or 5 inches of rain typically in PA. And we certainly want to protect streams, ponds, lakes, wells, springs. And if you're in an EV or HQ watershed, you're going to have some additional criteria that they need to follow in any kind of alternatives that you may want to suggest. Landscape resources, views from neighbors, prevailing wind, existing tree line, and hate to say this, but where their house is. If the prevailing wind is blowing one direction typically from the west, they'll say, A lot of farmers don't want to build a manure storage just west of their housing where they live. They just don't want to smell that manure all the time. So take a look at that. I hate to say out of sight, out of mind, but farmers do think about maybe putting manure storage out back versus out front. So keep those things in mind. Expansion and flexibility. Every one of us drives around, and when you notice especially the older farms, you have the old bank barn with multiple extensions on it. So farmers always need to think about what's the next generation going to do. Are they going to expand their numbers? Where the storage, where the manure is riding? And I think this is back to the team approach that, we're out here, whether we're NRCS Conservation District, PACD, or whoever, you're taking a look at these resource concerns, and you're going to be working with other folks, whether it's technicians, engineers, and even some consultants and builders to get some good ideas to work together to come up with a plan that really meets the farmers' objectives on their end, but also meets our conservation objectives. So putting it all together, you need to identify the potential resource concerns, but mainly we're collecting the data. What is the current situation? And I think a key to collecting current situation is also a lot of times that, hey, I'm milking 100 cows today, but my grand plan is I'm going to milk 300 cows in 2 years. So you definitely need to know what their future plans are. Identify the resource concerns. What we identify as resource concerns as conservation planners, as engineers and technicians, may not be the same resource concerns as a decision maker. And then our situation there is you need to educate the landowner that yes, you want a manure storage, but you have some other issues here too, that barnyard runoff going to the stream and those kind of things need to be identified. So when you go to boot camp 2 down the road here, you go to step 4 through 9. That's when we actually put all these things together. But again, this is boot camp 1, and that's the resource concerns on gathering the data that I typically look at when you're going around the headquarters, typically on dairy, but you can apply this to any situation. So with that, I'm going to pass it back to Tim and see if they've any questions in the chat. And if not, it goes off to Dan Ludwig. So talk to me, Tim.
Thank you, Pete. There are no questions in the chat, so you must have covered everything perfectly. Thanks, Pete.
It was covered to the nth degree. And folks, I know there's a lot of information. Like I said, go out to a few farms, get some more practical experience, and hate to say worst case situation, go back to our references we list in here and do some reading and research. And one last comment I will make: every farmer out there operates differently. And if you ask questions, well, what's your process there? How often do you milk your cow? All these questions, you'll find out that every farmer has their quirks and methodology, and they're all a little different. So ask questions, and most farmers are willing to tell you how they're operating today. So thank you, folks. And I'm going to pass it back to Tim, and have a great day.
Thanks, Pete. And folks, I did put a link in the chat where you can find that engineering worksheet document that Pete had mentioned that steps you through gathering information on the farm and then identifying resource concerns. So it's a great resource, and you can find that at the link in the chat. So with that, thanks, Pete. We will pass things over to Dan Ludwig. We talked with Dan Ludwig yesterday. He is our state resource conservationist. And so, Dan, at this point, it is all yours.
Oh, great. Wonderful. Well, good morning, everybody. Pete just provided a lot of good information. So I'm going to break it down just a little bit further, especially from the ecological science side of things, and really trying to address some of the planning side of things. So again, really what we're looking at here is focusing on the first steps of planning, the steps 1 through 3. And as for those of you that came to Intro to Planning, I'm going to keep going back to that. But, we really hammered hard on that. And, that's one thing that we want to keep in mind as conservation planners is, we really have this process. This process works, and it allows us to work through and make sure that we capture everything that we need to write that conservation plan. Sometimes the landowner's objective is to get funding to implement some of this stuff, and sometimes we jump from step 1 to step 4 or step 5, and really we're developing our plans, and then applying that financial assistance to help them implement it. So always don't, I just want to point out and remind you that these first 3 steps really are going to set us in the right direction, and it's pretty key to do your homework prior to heading out to the farm. Again, Pete did a great job of covering, some of the stuff that you should collect in the background. So again, it only takes a few minutes to gather some of this information. But again, soils map, soils description. There's been a lot of times that we go out to the farm and we don't always know where the wet areas are, where the hillsides are, what the steepness is. So really pulling those maps, and then the biggest thing is always check the files and see if there's any background information, an old plan or a plan from a previous operator. You'll be surprised of what you may find that's going to help you when you make that farm visit. A lot of, if you find those old blue conservation plan folders, you may find tile maps, you may find a lot of good information. So do your homework, and really look and see what you can find right there in the office before going out there. Other thing you cover is put together a nice field bag, something that you can take with you that has all the tools that you need. When we're going out and looking to assess our crop fields, we need a clinometer. If you don't have one of those, every office, I know somebody in every NRCS office should have one. I'm sure most of the district offices have those as well. But that's key for you being able to measure slope, so you can collect that information to use when you run your Russell 2 calculations. I like to take a hand level with me. If you have a 5 or 6 foot folding engineer roll, that is all great information. So on the fly, you can just reach into your bag, and if you want to check grade, you want to check where things are level, you have all that with you. The other thing is, prior to that visit, gather a lot of aerial photos. I love using Google Earth Pro, so if you don't have that, I strongly suggest you get that on your computer, because it has the background photos. You can go basically from whenever the last flight is, and depending on what area you're in, there's stuff from 2020 all the way back to 1993. Sometimes you might get something to 88 depending on the area, but that's really great to look at what's been going on those farms, especially you can see whether the crop fields were in strips. Did they have terraces or diversions or grass waterways? And over time, has the farming shifted? Have they abandoned those practices? It's really neat to see what's going on. It may give you some background ideas of what's going on. If the farmer calls you and says, "Oh, I've got some erosion issues," go back and look at those older photos, and that's going to tell you a lot to see if they might have changed how they're farming those fields. And again, talk to the producer on the phone if you can. Get some of the basic information. Does he have interest in program? Does he or she have interest in programs? Talk about what their animal numbers are and what they in the different types. What are their cropping systems, their tillage systems? If they have pasture, see if you talk to them about their grazing issues. So, try to get as much information as you can prior to the visit. That way, it's going to help you form how your field visit's going to go. And you want to make use of your time when you're out there. So The biggest thing is then when we get out to the farm, we want to look at, we want to do a resource inventory and evaluation, looking at what's out there on the farm, marking down. So you want to bring blank aerial photos of the farm. That way you can mark down where existing fences are, where existing watering systems are, existing grass waterways. It's going to help you when you go back to the office to start your planning. You're going to be able to have all that information with you. And as Pete said, you can't remember everything. So if you have that map, go ahead and just make some crude drawings and collect that data the best that you can. And then it's going to make that system a whole lot easier when you get out to the farm, especially when you're looking at your cropland, sitting, talking to the producer, getting a good understanding of his rotations, the equipment that he uses in his tillage operations. Mark Goodson's going to go. He does a good job at covering a lot of that. But again, if you're not familiar with all the different tillage equipment, we have a nice guide out there, nice little picture book. You might have them in your offices. I think we do have it on the Field Office Tech Guide. You can download and print out a copy, take it with you. And the biggest thing is when you're out there, don't be afraid to ask questions. If you don't know, if he says, yeah, I chisel and I use twisted shanks, and you don't know what he's talking about, ask him or her and have them show you. A lot of farmers are great in that aspect. If you show an interest in their operation, and what they're doing, they tend to take an interest in talking to you about it and explaining all that to you. So, and then, when you're looking at your pastures, one of the things that you're looking at is not only the animal numbers and the animal types, looking at, those pastures. Pete had an aerial photo where, you can see that pasture is beat up in one end, but then you need to walk out across that pasture and see what kind of forage is out there. Because when you start formulating your grazing plan on that pasture, you're going to need to know that information. And again, knowing how much feed he might supplement to those animals in addition to being pastured, and some of his objectives that he or she may want to do with their pasture, their cropland. The biggest thing is when we're going out to the farm, our goal is to at some point have that farmer implement an RMS level plan. And the RMS level is the resource management system. And that's where we're looking at addressing every resource concern on all the land uses. So, a lot of times we get busy. Contracting sometimes becomes a number one priority. So we tend to focus on the areas that the producer is interested in funding on, but we may not always get to all the areas. But really, when we're doing our assessment and filling out our NEPA information and doing the basics resource concerns, those soil, water, air, plants, animals, human, and their energy, a lot of those go across multiple land uses. So if our goal is to, at some point, get that farmer to implement an RMS level plan, he may not mention anything about the woodlot, but you need to take the opportunity to go out there and look at all the land uses and see what kind of resources are on the farm. It's fine if that producer does not want to address them at this time, but again, when we're doing our NEPA documentation and doing our CPA 52, we want to at least record what the benchmark is. That way we know what it's going to take for that producer at some point to implement an RMS level plan. So there's a lot of good information out there. We have different I&E checklists that you can use to collect information. Like Pete showed the CNMP checklist. We have one developed for pasture. So there's a lot of good information out there. And the last minutes that we have here, got a quick little PowerPoint to go through, kind of talk a little bit about, developing that conservation plan, looking at resource concerns. So let me get this started here. Okay, so you should see the slide. So, planning criteria. So again, that's what we use as the basis behind what we're looking at. So as Pete mentioned, so that's allowing us to look at what's the problem, how are we going to treat it. So as Pete mentioned, we have the 9 steps of planning, and really we're focusing on the first 3 steps. But here's all 9 of them that, over time, after you go through boot camp 1 and 2, we will have covered everything that's being addressed in these 9 steps. But our biggest thing is in step 1, we need to identify the problems and the opportunities. So what are the resource concerns that we find out on the farm, and what are the opportunities to address and correct them? We really need to take into account what the producers' objectives are. There may be some of these resource concerns that they're not interested in addressing at the time of your visit. But again, we need to record that because that's going to help us form and put together that conservation plan. And then really inventorying the resources. So that is a combination of a lot of different things. What kind of equipment does the producer have? What's his level of management? What tools does he have? If a producer doesn't have a no-till drill, can we automatically recommend that he switches to no-till because he or she may have erosion issues? We don't want to jump right to no-till if they don't have that equipment, but it's something that we can use as a conversation piece, if once we do all of our analysis, once we analyze the resource data, is that an option that he or she may have to seriously look at to address some erosion issues? So again, we don't want to jump to, going with these alternatives without knowing, does the producer have the resources to be able to do that? So I'm going to do a few things here of, what's the problem? So what's the problem here? If you want to unmute or type in the chat, you can. We getting the answers, Tim?
No answers here. I did get an email from someone that was having trouble using the chat. So, here we go. Some answers. Erosion, concentrated flow, soil erosion, concentrated flow, erosion.
Erosion. Yes.
Nutrient loss, erosion.
Aha, very good. So yes, our biggest concern here is, yes, we've got a concentrated flow area that's washing and causing erosion. This could be sheet and rill. Usually sheet and rill is across a larger area. So this may be the beginning of an ephemeral gully, but also obviously here we have a big sediment accumulation. So, and this is why we need to walk the entire field, walk the farm, because, if the farmstead's back here over top of the hill, the producer may not tell you about this. Sometimes they will because they may be interested in doing a grass waterway or terraces or something, but sometimes they aren't always up front with all the issues. So, if you don't walk over the hill and kind of see this back field, you may miss that. So, but again, yeah, good job on identifying some of those basic resource concerns. What do you think we have here?
Nothing in the chat yet, Dan.
Nothing in the chat. All right, so I'm going to point out this right here.
Here we go. Heaving from freezing ponding. Soil compaction.
Soil compaction. There we go. So this is a tillage radish, and that root has now made a 90-degree angle because it got established and it hit a compacted layer 2 to 3 inches below the soil surface. So, again, we talk about, some of our tools. Have a spade with you. Take your spade, dig a quick, and when you get to cropland, a lot of these compaction issues, you'll see them within the first 6 inches. You'll see that nice platy soil, but you'll find these platy soils. Or you can pop, if they're using some crops, pop that root system out and see what you got. All right. What do we got here?
Gully formation.
Gully formation. All right. So now, this is one of the questions that you have to kind of ask and determine is this a classic gully or is this an ephemeral gully? And what's, the difference is, can this gully be fixed by normal tillage? And I'm going to say probably not, because obviously they've been avoiding this concentrated flow area. So, this is, it's a classic gully that you're seeing coming from a road ditch, discharging into the field, and over time, it's cutting through, it's head cutting, and over time, it's going to get deeper and deeper, moving up the slope. So, all right, good job. So again, what is the problem? Again, we have to ask these 4 questions. Is it definable? Is it defensible? Is it consistent? And is there a consensus? Okay, so what we're looking at is, definable. The definition of it. Can we fully define what that resource concern is or what that problem is? Are our solutions science-based? So the alternatives that we give, should be, proven science-based alternatives out there, consistent, so nationwide. So when we're looking at our resource concerns, we want to see those. It's defined consistently from state to state. And consensus, when we're looking at how we treat those, all that information that we use from the science-based side of things is peer reviewed. So we know, we don't, when we're looking at conservation planning, presenting alternatives, we're looking at focused, defined solutions. And the biggest thing is we want to avoid using hearsay or just general thoughts and in general. We want to be using those alternatives that are proven and can be repeated over and over to solve those resource concerns. So when we're looking at resource concerns in our planning criteria, so essentially that's the level to what it takes to be considered as solving that resource concern. So this our resource concern list and planning criteria was just updated in October of 2020. So this is the new form. You may have seen some older forms that looks like an old Excel document. That's now obsolete, and now we're using this newer form. And what you're going to see is it breaks it down by each individual resource concern and then by land use. And it's going to tell us what tools we use to evaluate that resource concern and what the planning criteria is. So what does it take to consider that resource concern as solved? So, when we're looking at sheet and rill erosion on cropland, our tool to evaluate it is our current NRCS water erosion technology, or otherwise known as Russell 2. And typically we're looking to see if our soil loss is less than or equal to T. If we're at that point, then we're considered as meeting that resource concern. Looking at time here, I'm not going to go through, but you can see that each of our land uses have different tools that we use. So again, you'll see some of them are just client input and planner observation. And then on pasture, most of our resource concerns can be identified by using the pasture condition scoring and the score that you receive on that. So again, it's broken down, as I said, by each individual resource concern, and you'll see that sometimes we have tools, some of it is just what you see in the field, but again, what we want to pay attention to is the planning criteria. What does it take to consider the resource concern solved? Okay, so looking back at that first picture we looked at, soil erosion. Again, we're looking at detachment of the soil particles. If we ran that, when we ran that in Russell 2, we're probably going to see that based on the cropping rotation, the tillage, our erosion rate is probably greater than T. So then we're going to be looking at what needs to be changed within that cropping system to bring soil erosion down to at least T or even less. Okay. So then on pasture, would we even consider this a pasture? Probably not, but we also see that, yes, there's some major resource concerns as far as soil erosion, sheet and rill, because there's basically nothing in place other than a bunch of rocks to hold the soil in place. So then when we're looking at soil erosion on concentrated flow, now that's an older term. I got to update this slide, but now our soil erosion is broken down into sheet and rill, ephemeral, classic